This video should only be watched after watching the orbital diagram video, because it will not make as much sense if you haven't done it. In the orbital diagram video, we did an orbital box diagram for bromine, and if you haven't watched that, you should go back and watch that. So now we are going to see, starting with this orbital box diagram for bromine, we're now going to learn how to do an electron configuration. An electron configuration gives exactly the same information as an orbital box diagram. It shows where the electrons live, how many live in which sublevel, and so forth. But it does it in a different way. It doesn't draw it, it writes it out. It writes it out in as a series of numbers and letters. And so it still follows the diagonal rule, which is back here. So we're still going to go in the same order: 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, blah 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 blah. We're still going to do all that, but this time we're going. Yeah. This time we are going to not draw it, but say it. So we are going to start with this sublevel right here, and what is it? Well, that's a 1s. How many electrons live in there? Well, there's 1 and 2, so there are 2. We show the 2 as a superscript. The 2 there, the superscript number, is not read out as squared or to the second power. We just read it simply as 2. So that would be 1s2, to indicate that there are 2 electrons that live in the 1s sublevel. And then according to the diagonal rule, the next thing to fill up is the 2s, which also contains 2 in that sublevel. And then according to the diagonal rule, it's 2p comes next, and so we're going to go 2p. And this time, not only 2, but 6 electrons can fit in that sublevel, so we go 2p6. And we just continue doing this until we get them all accounted for. The next level would be the 3s, and 2 live there. And then 3p would contain 6. Refer back to the diagonal rule, we'll see that after the 3p comes actually the 4s, which there are 2 electrons that live there. And after, whoa, did I do that right? Yeah, I did. 3p, and then I got a little bit of a brain fart there, but I'm back now. After the 3p, we got the 4s, and then after the 4s, we go back down and we do the 3ds, and so 3d, and there are 2, 4, 6, 8, 10 can live in there. After the 3d10, we get to this sublevel, which is 4p, but this time we're not going to write 6 because there are not 6 electrons there, there are only 5, 2, 4, 5, and now we are done. That is the electron configuration for bromine. 35 electrons all accounted for. If we count up these numbers, 2, 4, 10, 12, 18, 20, 35, we can see that we do have the correct total. So that is the electron configuration. Follow the diagonal rule, put 2, 6, 10, or 14 electrons in each sublevel as appropriate up until you get to the last one, which you're going to put as many as you need to make the correct total that you get from the atomic number. Finally, these highest level electrons up here, these guys, those again, if you saw the last video, those are called valence electrons. And so we can actually do something else called the valence electron configuration, which is exactly the same thing as we just did, with the exception that we ignore anything that is not a valence electron. So we could rewrite this whole thing only including valence electrons, which of course are the electrons on the 4th floor. So which ones are on the 4th floor? Just the highest electrons. Well, these are on the 4th floor, and these are on the 4th floor, and so we would only include those: 4s2, 4p5. So that is the valence electron configuration.